every single one of these, come on guys, every single one of these graphs all start out the exact same way. Whether we're talking about graphing the square root of x or graphing the cube root of x, they all work the same. On the regular old boring whiteboards, you'll notice I kind of sketched out some real generic way that the graphs are going to look. If you just use tables, numbers that are perfect squares, just to plot some very simplistic y equals the square root of x, obviously I'm looking at positive values because I'm not taking square roots of negatives here. So this is generally going to be a first quadrant problem. So if I use x is 1, what's the square root of 1? 1. If x is 0, what's the square root of 0? So I know I'm starting at 0, going to 1, 1. What's the next perfect square? 4. If x is 4, y is 2. And so on and so forth. So the curve looks like this. It just continues. What I've done there is I've plotted just a couple of perfect squares. When you're looking at cube root functions, it's generally the same exact thing. But one thing you'll notice is that can you take a cube root of a negative value? No. Yeah. When you have cube roots, you can have negative values. That's okay. So when you start looking at what a generic idea of that looks like, what's the cube root of 0? What's the cube root of positive 1? 1. What's the cube root of negative 1? Negative 1. What's the next perfect cube? 8. The next perfect cube would be 8 out here, and that would be up at 2. Do you agree? If it was negative 8, it would be down here. So your cube root function looks like that. What I'm doing here is I'm just plotting perfect squares for the square root function, and I plotted some perfect cube for the cube root function, just to get the general idea of what these graphs look like.
So it's 8 on the x.
Yeah.
2 on the.
Yeah. I just moved it all the way out here to say this was 8. I'll throw that 8 there. And again, if I took the cube root of negative 8, the y value would be negative 2. I can take those cube roots. So what happens here then today is that we take these values and we shift them. Every single one of these graphs works out to be the same generic setup. What we do here is we take these values of a square root function. For example, well, I'll come back to the a, h's, and k's here in a second. But if I'm looking at a square root function, let's say it's y equals negative 2 square root of x. What has changed from just y equals the square root of x?
That is negative 2.
Kind of. It's a negative 2 out in front of it. So I'm multiplying the original graph by what?
2.
Negative 2. So when I go to plot these style values, this negative 2 value is your A. All right. When you go to plot this, when you're looking at square root, the points that you would plot are going to be 0, 0, 1, 1, and 4, 2. Do you agree? That's what your generic y equals square root of x would look like. Now, if I take those values and I'm going to shift them just by an a value, after I take the square root of 1, I got 1. What's 1 times negative 2? What's that? Yeah. So, well, let's start with this. When it's at 0, what's the square root of 0? What's 0 times negative 2? 0. So it stays here. When it's at 1, square root of 1 is? 1 times negative 2 is? What's down here? When it's at 4, what's the square root of 4?
2.
What's 2 times negative 2? So what we've done is we've transformed that graph. Yeah, exactly. What you're doing is you're working with perfect squares, 0, 1, 4, and you're working with perfect cube roots, 0, 1, 8. You're plotting those points via what they would look like normally, and then you shift all of them. And this example was just a plain old shift of the value of A. Excuse me. When I shift things around that has an H and a K, do you guys remember what the H's and the K stood for?
The points on the X and Y.
All right, so what do I shift at H? How do I shift it that way? Up and down or left and right?
Left and
Because H stands for horizontal. And K is vertical. So your generic idea, oops. Nah, I don't want to use this one. If I have y equals a square root x minus h plus k. I'm trying to overemphasize putting that plus k value outside of the radical. Trying to overemphasize it. The h value is on the interior of the radical, the h value is on the outside. And you've seen ah's and k's before. So if I have the equation y equals 2 square root x minus 1 plus 4, what is your value of h? Is it 1 or is it negative 1? It's 1, very good. So this means that my a value is 2, my h value is 1, and my k value is 4. So now when I go to start the graph on this one, I'm going to sketch a graph of I always start with my a times the square root of x. I always start with that sketch first. Because a lot of times that a value, you're going to be able to multiply in your head. You're not going to have to worry about anything. So if I start with my sketch, it would be the sketch of y equals 2 square root of x. What's the square root of 0? What's 0 times 2? So I know it starts at 0, 0. What's the square root of 1? What's 1 times 2? So at 1, it's at 2. And then again, I go right to the next perfect square, which is 4. What's the square root of 4?
2.
What's 2 times 2?
4.
Now, this is my initial rough sketch. With this being the initial rough sketch, yes. Should I make that a solid or a dotted line, you think? Dotted. I always make this the dotted line. Because it is the rough idea of what this graph is going to, bless you, is going to start to look like. Because the second step of graphing these is now just to shift it H and K. So now for each one of those points, I have to move it to the right 1 and up. Shut these off if I see it better. That snow is really glary today. Okay? Since my shift, my H is 1 and my K is 4, I go to the right 1 and I go up 4 on each of those points. Right 1, up 4. right 1, up 4, right 1, up 4. And there's my new curve. And now that is the official graph. It becomes solid.
Do you move this way?
I should have. Yeah, I did. I started. That was my first one. I moved this one over,
Oh.
and I went up 4. Because now, if you think about it, that graph starts there, doesn't it? Because if I substitute in 0 for x into this equation, if I substitute in 0, can I take the square root of -1? No, I can't. So what that means here is that you can actually state your domain and range. Do you remember what domain and range stood for? What was domain? What comes first in the alphabet, domain or range? What comes first in the alphabet, x or y? X. So what do you think domain goes with?
X.
All right. So in this example here now, with my shifted problem, my domain, x is greater than or equal to 1. It cannot be smaller than 1. And what would your range be?
Greater than or equal to 4.
Good. The range is going to be the y values that are greater than or equal to 4. That's basically it. Your domain is going to be all values that are greater than or equal to 1. I can't, once again, I can't substitute in 0 into this shifted AH and K equation because it's going to ask me to take a square root of a negative. That's bad. So we don't worry about these. We're talking about all real solutions here, all these real graphs. All right? Again, as we go through these things, you should notice that it really isn't horrible. It's just a matter of plotting your A value with whatever the root is and going from there. Let's try another one with the cube root. Yeah.
Is the domain and range always gonna, or are they always gonna be range?
This is dumb luck. This is dumb luck. Let's try this one. Let's look at this one. If y equals 3 times the cube root of x plus 2 minus 1, when I start these problems out, I always want to go ahead and list out my a, h, and k so I don't forget. What's a?
3.
What's h? Good. And what, the -1 is your k value. This is a cube root function. This is a cube root function, which means I'm going to use 1s, -1s, 0s, and an 8. So when I go to start my rough sketch, I rough sketch 3 times the cube root of x. When I do my rough sketch, it's going to be dotted lines. What's the cube root of 0?
0.
What's 0 times 3? 0. What's the cube root of 1? 1. What's 1 times 3? So at 1, it's at 3. And then what's the cube root of -1? -1. And what's -1 times +3? So again, this is going to look like that.
You have to do those two.
Yeah, because a lot of times we get into some of these shifts. I should have mentioned this. When we get into some of the shifts, if you plot out that value of 8, 8, 2, it's going to be way out of, sometimes it can get really, really out of whack. I'm okay with just bounding around one, plus or minus 1 and 0. Yes, sir.
Why do you like just kind of forget about the H and K and just do the cube root of x?
Because now when I take, this is the generic of what the generic graph looks like. To this, I move it H and K. So now each of these points, I have to move it to the left 2 and down 1. Yeah. So I'm moving left 2, down 1. So I start here, I move it left 2, and I go down 1. I'll change color. Left 2, down 1. Left 2, down 1. And there's my new graph. And when I've done plotting out with the shift, I just make it with a solid line. You're going to see H's and K's, and I've mentioned this before. We do lots and lots of H's and K's. A, H, and K, A, H, and K. Same idea. A changes the, I don't know, for lack of a better term, the amplitude of how fast or how slow it rises. And then the H and K just shifts it left and right, up and down. Was I okay in assuming that the graphing really isn't going to be that bad? Let's see if I get one in here with a negative value. All right, try this one then. I'm trying to decide if I don't know. To be honest with you, I don't think we really need graph paper. Unless you really, 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 really want graph paper.
No.
I like the idea of the rough sketch of the shift and that we're just kind of plotting things through. Take a few minutes, try that. Let's see if you caught it. A is -3, H is 7, and K is -4. Start by graphing what the generic would look like for -3 cube root of x. So I start my generic. I know it's going to go through 0, 0. The cube root of 1 is 1. 1 times -3 is -3. So this graph is going the other direction. Did you catch that? Yes. Good. Oops. Forgot to turn. For lack of better drawing skills, that's kind of what it looks like. To all of those points, I move them right 7 and down 4. So like Mamer was just saying, this becomes where? At 7 and -4. Everybody agree with him on that? You hear that we're agreeing with him. And then the next one, I know you're right, the graph is going to be kind of weird, would be at what, 8 and negative. And this one would have been at, what was it, 6 and -3? No, -1, thank you. Sorry. I forgot what point I was looking at. And we know it's just going to go like this. Let me ask you this now. In this graph, what's your domain? What's your domain here? Is there any value that x doesn't work? No. So in this case, since there's no values of x that it doesn't work, my domain is what about my range? Is there any values where the range doesn't occur? The y value doesn't occur? No. If you look at these arrows are just continuous. It's going to take forever to get it larger and larger and larger and smaller and smaller and smaller, but it will get there. Yeah.
So for all cube root
It's more, yeah, you're going to be all reals. It's your square roots you're going to have to worry about more of your domain and range because you have that end point where you can't have that negative root. It's a great point. Yes, sir.
Right. How are you getting those points, the 6, -1?
We took 0, 0, and we added 7 and subtracted 4.
Yeah, I got that, but how'd you get the 6, -1, and the 8, 7?
We took -1, comma 4, and we added 7 and subtracted, oh, sorry, that's the 3, and subtracted 4. So you add 7 to -1, you get 6. Take 3 and subtract 4, you get -1. We're adding and subtracting that h and k values to those order pairs from the original, prior to the shift.
Okay.
That's all. Yes, sir.
I don't even know like what I did here. Like it's not even the right way. I did like that.
Oh, you graphed it as a +3 instead of a -3. You didn't catch the trick. What happens here is when you have a negative, it's going to flip the graph. Instead of going increasing, going that from left to right, it's decreasing going from left to right. That's what you didn't catch the negative. Oh man, what do you got?
Can you explain the domain and the range?
Domain again the domain is your x values, your range are your y values. In this example with the cube root function, your domain and range is going to be all real numbers because there's nothing that stops it. When you have a square root function, like we did here, if I used 0 into this function, I'd have a square root of a negative value. You can't have that, so it's got to be all values greater than that 1. Same thing with the range. The range can't fall below that value. So it's got to be all the y values bigger than that. All right. Yeah.
So when you had a positive absolute value for your x, or your y has to be greater than 6.
Yes.
And so is your x.
For absolute value? I have to look at it. I'm trying to count. Give me a second. What I'm doing here today with the problems here, guys, is that I've got a mixture.